React Native EU is back for an on-site edition. Write that down. September 7th and 8th in Wrocław. You can expect industry thought leaders, insightful talks, networking with great devs from all around the world, and of course, good vibes only. Write that down. September 7th and 8th. Wrocław. Get your tickets now. Do it.
Hello, everyone, and welcome to the React Native Show podcast. Today, we're going to talk about databases in mobile applications. So to do that, I invited Andrew Meyer, who is a ex-stuntman and software engineer from MongoDB, and we'll be talking about Realm. So Andrew, hello, welcome to the show. Can you please introduce yourself?
Yeah, hello. I'm Andrew Meyer, as we've heard. I'm a senior software engineer at MongoDB. I've been there for about 2.5 years. I was hired on the Realm JS team to basically do the React Native integration. So classically, Realm JS was developed for Node applications as a kind of like a server language, and people were having troubles using it in React Native. So I've been helping with the React Native integration. And yeah,
awesome.
I classically come from a React Native background. Before I was hired, I was a React Native developer since about 2017. So, yeah, somewhere around React Native version 35 or something like that.
Yeah. Oh, yeah. Okay. So that's quite a long time ago, the 35.
Yeah, like before CocoaPods was part of the whole equation.
Yeah. Can you please maybe explain to me as a newbie in like databases environment, what's the difference between like MongoDB and Realm?
MongoDB is a server database like application. So you're basically running a server, running the service on a server that's listening to multiple connections. It's for handling a lot of concurrency, and Realm is actually a local database on your phone. Mm-hmm. So it's basically only just handling that single user at one time. And also between the two differences is how you access the data. Like in MongoDB, you use queries and get some JSON back, whereas Realm is integrated within your language. It's an object store, so you basically get objects back. They look like JavaScript objects, but they're actually Realm objects. Mm-hmm. If you access them, it's actually running C++ code that we handcrafted. So it's super performant, super fast, and you don't really feel like you're working with a database. It just feels like you're working with native data structures. So that's kind of the difference. Or MongoDB, it's, yeah.
I guess we'll be talking about like Realm functionalities and some Realm technology in the later parts of the episode. So what I want to start these episodes from is to briefly go over like the data in mobile in general. So not only databases, but also like data structures and the way we handle persistence data. So can you tell us something about the history of databases in mobile? Before we had Android and before we had iOS, there was Nokia, right?
Right. And yeah, Nokia had their own, I think it was called like Series 30 and phones, and they didn't really have a database because we didn't have applications back then. So they weren't, you basically just have these like little apps you would run, right? There'd be like, storage of contacts and stuff like that, but it wouldn't have like a classic database the way you would think about it today. It wasn't until their later models that they actually started having like SQLite involved. So if you're just going to run, Snake on your phone, you don't really need a database, right? But it wasn't until the application space started where we really needed some more data-intensive applications.
And SQLite was already developed and already in usage in Nokia phones.
It wasn't. It didn't get there for a while, actually. Like SQLite was originally developed as an embedded system database for battleships. Actually, I think for like missile targeting systems. And so, yeah, there wasn't really anything available at the time that was just running locally on a single chip that someone could access. Most databases ran on mainframes, so it was originally developed so that they could run it, basically on a single application. And then it was open sourced and picked up by the Android team as basically the database that Android applications are going to use, and then started becoming the mobile database that exists on Android phones. So it was pre-baked into the phone itself. And if I'm not mistaken, it's also in iOS devices as well by now.
This is also my knowledge that iOS devices and Android devices have that SQLite integration already there, available.
And iOS also had another database that was called Core Data. This was actually a super antiquated system out of the Next OS era, like way back when. Next is the X, and Next is where the X and Xcode comes from. So that's like how far you're going back. Like,
oh, really? Okay.
Like pre Macintosh, right? So Core Data, I guess, from what I've heard, I've never used it, but I've heard that it was extremely difficult to work with. Like if you got it wrong, it would just crash. And
I think we have Objective-C from the same reason, that it used to be in Next operating system, and then it got picked up by iOS as well.
Right. Yeah, it were just like Mac apps in general, like Macintosh apps in general. So like that whole
So what is the story going from like this embedded database SQLite that you have already on Android and an iPhone? What was the reason that Realm was created then?
So I talked to the founder, Alexander Stiegson, sorry. He actually was working at Nokia, and he left the company and wanted to make his own company where he's developing a code editor that was collaborative, kind of like Google Docs now. And so he was trying to figure out a way to do that using the tools like SQLite and things like that, because even if you're making a desktop application, it's still a local database. It doesn't have to be on a phone. So, but he was having thousands of crazy relations as you're dealing with every single change that occurs and all these change sets, and just finding that SQLite wasn't performing. And so he decided to boldly just try and develop his own database. And then he realized this could actually be the company that he could be starting. And so he was working on that and decided in 2011 to just try apply for Y Combinator. And they got accepted, and they moved to San Francisco. They were originally in Copenhagen, and basically started Realm database. And I think they got picked up, started gaining popularity around the time Swift was released. They had originally, the big project that they worked on, Y Combinator, was like an Objective-C version of Realm. And as soon as they were about to release, WWDC just announced that they were releasing this new Swift language. And so they had to quickly panic and adapt. And so they created it for Swift. So, yeah.
And one interesting bit of information there is that at the same year that Realm was in the Y Combinator, another very popular solution was in the same batch as well, right?
Right, exactly. So Firebase was also an alum that year. So Alexander was working with the owners of Firebase at the same time, collaborating on databases in the mobile space. So yeah, and they both kind of branched off in their own different ways, as we can see.
Yeah. We will make some comparison to Firebase and Realm in the end of this episode. So going back to the initial question of why do I even need a database? I'm a React Native developer, and like I'm completely satisfied with the options that I have, the options that are really easy, and I don't have to add any additional package to get. So what I have right now is async storage, which, sorry, it's not true. I do have to add that package. It's no longer in the core. But like this is
Right.
very like plug and play, right? Async storage.
Yeah.
Which you could call a very, very simple database, couldn't you?
Right. Like async storage is a key value store. So it's a very simple database. It's at the end of the day, it's just a file, right? So you make a key, it's saving a string, and that's it. You have different keys for different strings. In the most case, the string is a parsed JSON object that you have to stringify to save and parse to get back into your application. So for simple applications, that's really good. But if your local data is significant, it could take some time to load that and hydrate it, and also to keep track of it, right? To track the state on it.
Yeah. So like going on with your like growing example, if I have a growing data structure, then I opt for Redux or Mobex or other state management libraries, and I can persist my data and then hydrate it. And I guess under the hood, they still use the async storage, but then I have some more fine-grained control over like the shape of my data structures.
Right. And that's a valid option. I mean, it's legitimate. But at the end of the day, like you have everything in memory at that moment in time, right? You don't have any, and you're constantly just reading your object. You're updating your state. It's you're persisting it. Like you have that whole stale data that you can look back on, which is kind of nice after a while. But if you don't need it, you don't need it, right? You're not cleaning up as often. So you're building this giant state tree and this giant memory space when you're using the state management systems. And classically, that's good. Like for web, that makes sense, right? In web, you don't have a local database. You're getting information usually from a REST API, and you need to just store it in the memory of that browser and work with it and manage that state. But when you're on an actual like mobile device, you can leverage the hardware that's in your hand, right? And you could actually have a database that stores all this information and accesses it in a way that is super performant, is putting it in memory the way it's supposed to be, and not just relying on the JavaScript runtime itself to handle the memory. Which you do any research into that, you kind of know that JavaScript isn't really super efficient when it comes to memory storage. Right.
Yeah. And what would be, so I guess at the end of this ladder, we will talk about Realm. What would be the step between state management libraries and persisting and hydrating those and Realm? I guess the SQLite kind of things. What are those?
Right. So you could leverage the SQLite that's on the phone right now using, I mean, you could just leverage it and write these SQL strings yourself, and but typically people don't want to do that. They don't want to write all these SQL statements all day. It feels like a class you took in college, right?
Yeah.
So there are a lot of ORMs out there, so object relational mappings, and basically that's kind of an object syntax on top of the database. So as you're accessing this object that's kind of modeling the data that you have on your phone, it's automatically under the hood making these SQL queries for you, and update queries, select statements, filters, and all that under the hood. And that's fine, but it's kind of a pain. Like if you, for example, have like a collection of data with some sub collections, then you have to create a join table, or if you want to have a many relationship, like You have to basically have another table in your database that's just IDs that link things together. And if you say get a person out of the database and the person has a collection of dogs, when you do .dogs, they don't exist yet. It has to go and query now. It has to go do a join under the hood and then populate that for you, right? So there's a lot of these queries that are happening. And if you want to do anything more complex, maybe at the end of the day, you still end up having to write these queries yourself. Like for the most part, ORMs handle about 95% of what you want to do. But if that 5% is when you actually have to get under the hood and learn how that database works.
Yeah. I wonder also about like type safety in this kind of applications and like dev experience, the autocomplete, stuff like that. How is that? How does that work?
It's basically you'd have to model that yourself, right? You have to write your own types on top of that, and hopefully expect that that's what's going to come back from SQL itself. The types aren't generally like one-to-one mappings from TypeScript to what you have in SQLite. Realm also has its own types that don't completely map, but we've created like a class-based model syntax for Realm, so you can model your data in a class, which directly maps to what Realm will be. It's actually we came out with a Babel plugin that kind of reads the class and actually like generates the schema for you. It's a bit of a experiment at the moment. I'm kind of thinking more in the way of like going in a code generation route where like you define your models, and I don't know if you've used GraphQL before, or like GraphQL code gen where you can write your GraphQL queries and then just runs over your code base, and then you get these nice like these nice convenience functions you can use, or convenience types that are just modeled off what you have. I think that's something we're going to look into in the future. But at the moment, you define your things in class, you get them typed, and what comes out of your database is typed, right? When you say, give me all the realm.objects of a person, you pass that person class in there, you get a person back that's typed, you get the autocomplete, you can see what types it has. At least for most of the ORMs I've seen, you basically get your objects with a string saying like the collection I want is called persons, and that's a string, and then you have to use a generic type that you self-define to get that out of there.
Oh, okay, yeah.
Right.
So if the ORMs are SQLite, so relational databases under the hood, how is the Realm different? How it differs from relational database, SQL database?
Right. So Realm is an object database, and which basically means you get these objects back. We talked about that a little bit earlier. But it's not an interface on top of an existing database. Like you're accessing Realm directly. Classically, all the teams that we have in our organization are based on the platform and languages that people develop apps in. Right. So we have a Swift team, a Java team, Kotlin team, Flutter team, and they are developing basically a layer on top of the core. They're writing in C++, so that you get a version of the database that looks exactly as it should in the language that you're using and uses the same paradigms.
And then you are doing the bridge on top of that and giving us the React Native.
Right, exactly. So we had a JS version that was exactly, feels like JS. And then I created a Realm React library that's basically providing React hooks and providers so that you can access that data from Realm.js, right?
So with all that said, what is the actual benefit I get from this being an object database?
The benefit you get is ease of use. Like, it's a nice developer experience. You don't really have to think about how your data is being stored in an efficient way. You can just access it directly. And also you get speed out of it as well, right? So you get, instead of just having these JavaScript objects that you're working with all the time, like you get memory optimized versions of these objects. And we can go in a bit more detail about how that's done.
Please.
Yeah.
So, like on high level, I can see the difference. I can see the analogy to like old architecture of React Native and new architecture of React Native. So old architecture is a bridge that needs to send the messages as a JSON. It needs to be parsed, decoded, stuff like that, right? And the native layer then has to like act on those things. So that's like ORMs, right? Then I have the SQL statements that needs to be understood and blah, blah, blah.
Right.
In this example, the Realm is new architecture when I have just direct access to C++ objects that are my state, that are my data.
Right. And you also get the benefit that the data that you get isn't a copy of your data. It's actually the live data. So you're actually seeing the live results. And the way we manage that so that you don't run into issues is that if you're updating that data, we have these write transactions. So basically you define a transaction, realm.write, you give it a callback, and when you're inside of that transaction, you're able to modify that data directly. And if you have multiple transactions happening at once, Realm core underneath knows one transaction after the other. If you do something that you're not supposed to, then it's going to roll that transaction back, right? And then it's going to invalidate it and your data is going to be fine. Right?
Okay.
So that's something a bit different. Like normally, if you're using like a state management and you modify the data directly, it's only modified for that moment in time, but it's not actually saved, right? If you tried to modify anything that you get from Redux, right? But you would have to go that extra layer, sending a request to your state tree to update the data itself. But with Realm, you can just update it directly within there. And I guess the next question is, how do you get updates then? Like, how do you know that your data updated? We also have event listeners that you can apply to, but you don't have to when you're using Realm with React Native. With the hooks that I've developed, I've actually created the event listeners for you, which will return an update. It'll basically trigger a re-render whenever any of the data updated, if it's relevant, right?
Okay, so maybe we can actually start discussing this part.
Right.
So, and we will go back to the nice things and user experience and all of that as well later. But maybe while we are in event listeners, can you please try to explain to how do I start using this? How is it built on React only side? What are the paradigms that you are using?
You mean what you would do to get set up with Realm today, like in React Native?
Yeah.
Right. So npm install Realm and at Realm/React. Those are the two libraries. Realm itself being the Realm.js SDK, and then at Realm React being the React Native layer on top. And then you would think about how you want to, what data models you want to save. So you would write your classes, right, or your data models, basically defining a schema of what you want to do, and then you input the Realm provider in your application to wrap your app, and you provide that with an array of schemas, right? And these schemas are actually the classes that you defined. Yeah.
Schemas are just the JS classes?
Yes. There's actually, if we get down into it, there's actually two different ways you can model data. Before TypeScript was huge and classes were kind of big in JavaScript, we just use schemas, schema objects themselves. So basically, it's just an object. It has a structure that you have to adhere to, which is a name field, which is the name of your model, and then a properties field, which shows you which properties are going to be in that model, right? And each property can be like name, which is the type of string, age, which is a type of integer, birthday, which is a type of date, And then you can even go further. Like if you can set up like object links. So if you have children for a person, then you can say, okay, well, I can just make another person that it links to. And then, so you can even self-reference the same model within the model. Right?
Okay.
Or dogs, you can have a dog object and have that also represented in that class. So, and then after you have those schemas defined, then you wrap your app with the Realm provider. And when you want to use that data within your app, then you import use query out of Realm. You pass that in that class that you want to get out of it, and then it will return the collection of data.
Okay.
Right.
And yeah, please continue.
Right. And if you want to filter that, since the last version I just released, usually you would just call .filtered on that and wrap it in use memo or something like that. But I created a second argument to use query, which is a callback, where you get access to that collection that you want, and then you can call .filtered within that callback, and then you get a memoized collection back. So it's just gonna you can even pass in a dependency array if you want to. Let me go back to .filtered. .filtered has like a query syntax, like age greater than 5. Give me all the persons with age greater than 5. So you put that in there, and now you're going to have a collection that's always going to have all the people that with their age greater than 5. Right.
No, okay.
And then
I was before you said that, I was going to say, oh, okay, so this is almost like selectors in Redux, so that I get my data and then I can just pick something else from it as well. But then with the introduction of this conditions, right? You can actually select data more precisely.
Exactly. And what's kind of nice is you can call sorted as well, which can define how you sort that data. And imagine you're displaying a list of people and your UI has a way to filter and sort. So if you have a use state up above that's basically keeping track of what you selected for filtered values, then you can use that state as a dependency array into use query, so that it will rerun that query when those objects update. Say that age is a scroll, and you need to select which age you want. And you move it to 10, then it's going to re-update that query and say, okay, we actually want people that are greater than age 10, and we want to sort it alphabetically from descending. And that could change as well. And that happens really fast. It's it doesn't need to make an extra SQL query when it does that. It's just modifying that internal query, and you'll get the results back.
So I want to touch on something that we discussed with you and some other people from your company, from Realm. I could say MongoDB, your company, but that I've heard this nice phrase that mobile is ultimate distributed database. And on top of that, you have just released this new feature of synchronization between, maybe you can say that, what the feature is and how it connects with this distributed database.
Right. So since Realm's marriage to MongoDB, we have access to all their enterprise or their server offerings, right? The Atlas app services, and with that, you're able to have a global database that actually can communicate with that local database. So each of these applications that are out are basically having a copy of that global database that MongoDB offers and synchronizes with it, right? So now you have basically a distributed system of many different mobile devices out in the field that have various network connectivity issues, or maybe they're offline, they're able to access their data, they're coming back online. Now they need to say what's changed, what's different, and basically the the server will handle that for you and actually be able to send change sets from other pieces of that data and be able to come back and have the exact reality of what the world is in that moment, right? So moving on to that, so that's basically what we like to call an offline first architecture. So your data, when you have a local database, you'll always be able to access your data when you're offline. You know, if you very first time open up the app, you have nothing, right? So you have to download the data that you need at that moment in time. And we have a trick for that. It's called flexible sync. Basically, you subscribe to a subset of that data that your app needs. Typically, in most apps, it would be just your user ID is probably what you want to filter your data on when you authorize, right? And then you can start, working on your data. And after that's done, then you basically have this offline first app. You can edit your data at any time.
So Andrew, from what I hear about the synchronization, this offline first part, is that I could theoretically have my database be a substitute to my API calls, to have only data being populated through database and not through calling the API.
Right. So I like to think about it. So in classical, architectures, for web applications or any other mobile applications, right? You usually making REST API calls to an API and caching the result. If you need to update things, then you have to make a request, a post request to update that data. And then you have to do another request to get the data back. You also have to set up probably some sort of subscription, like a WebSocket or something, or some sort of polling to keep getting the most updated version of that data. But when you're using Realm with Sync, it's basically like your database becomes your REST API, right? So as long as you're setting up a listener to that collection of data, you're always getting, as long as you have a network activity, you're always getting the most updated thing. It's already subscribed to changes, and you get updates when those things change. And if you write to it, it's automatically going to update what's in the cloud.
So, yeah, the challenging example that I can think of when it's quite hard to synchronize is chat applications, right? Because you need it to be fast, reliable, all of that, and on time. And I feel if someone takes the burden from me of doing the hard work of synchronization, and I can just focus on creating the UI, and it's gonna work, this could be a very good use case to not do the API completely and just rely on the database underneath.
Right, exactly. So we just take all the hard work out of it.
Yeah,
you could basically use something like flexible sync to apply to a chat room, and then then you just get the subset of data from that chat room. So you could easily have multiple chat rooms running against your MongoDB cluster, but what your mobile app that's currently subscribed to that chat room will only see the changes it's interested in, and that should happen quite fast.
Yeah. So I hinted in the beginning of the episode that we will compare the Firebase and Realm. So let's do that now. Let's maybe have that comparison. What I can do with Realm and what I can do with Firebase? What are the differences there in possibilities?
They're definitely very similar in terms of what you can do, right? Firebase let's talk about Firestore. I'll talk real quick. There's two things that Firebase offers. They have the real-time database solution and the Firestore solution. I would recommend, if you're going to use Firebase, look at the Firestore solution, while the real-time database is it's basically just storing JSON at the end of the day, right? It's just an object, and Firestore, you can set up collections and sub-collections. But what is the difference between Firebase and Realm? They both offer synchronization. They both offer queries. You get your updates. But Firebase is, when it comes to local, right? I would say Firebase is more remote first, whereas Realm is more local first. right?
Mm-hmm.
You are able to work on your data in Firebase when you're offline. It will store all the transactions you're working on as you're making updates to it. But I was just reading through the manual. At some point, like if you're setting up a really complex transaction, and you restart your app, you will lose those changes that you just made. So in Realm, it's a bit different. Like we're also like, you're making all these changes to your database. We're also keeping a change log that's going on, but we're not going to wipe that out for you. Like your local database will be the same. There are situations, of course, where you can get in the situation that, like, for instance, if your app's been offline for a very long time and the schema has changed on your MongoDB data, like the structure has changed, there's like no way you're going to be able to migrate. Then basically at that point you can just wipe the data on the phone and get the latest changes downloaded, right?
Something that I picked up from our conversation previously is that it works similarly to Git, right? When you have conflicts, you have to resolve them. Sometimes it is not like you said just now. Sometimes it's not possible to resolve the conflicts, but you can have everyone has this distributed version of code. You can make your changes locally, and eventually, after you push resolve conflicts, it will be what's the word? Consistent on eventual consistency. It's called,
right?
Yeah.
So that as you're working on that copy of your data in Git, at some point you're going to want to merge those with the changes that are up there, and you do that in the local. You could obviously just say from your client force push and override all the changes your teammates made, but I'm sure they're not going to like you after that. Sure. So yeah, it's very similar. The same type of problems that you would have to solve with merge conflicts is kind of what we're solving for you with Realm data and in a cloud database.
Okay, so maybe let's talk a little bit about the use cases. We touched on the very simple solution like async storage and like state management libraries. But then what is the step? What are the use cases that you would advocate to use more advanced solution like Realm?
I think even simple apps like could benefit from using Realm. As if you ever need to do anything, especially with Realm and Sync, if you ever need to do anything with a backend and you're setting up an API and a backend server and a database, thinking about distribution and things, like it's nice to just use Realm right away, because then you don't have to like think about these optimization things, right? It's not hard to get started with Realm, and like there's a classic, like, don't pre-optimize your code because you'll never get to release. Well, if you just start using Realm and Sync right away, like you're basically pre-optimizing without wasting any time. So that's definitely, well, we'll move on to the next point. Like, what are specifically good applications for Realm? If you're in areas with low latency, say if you're creating a logistics app and you have truck drivers using a mobile app to know like where they have to deliver their packages to, you don't want them being out in the middle of the country trying to see, okay, where's that address, and all of a sudden they get a loading spinner. Or at the same point, they want to report right away that their job is done and that they've delivered their package. And if they can do that with Realm, they can simply modify that data, and as soon as their mobile device gets network again, it's going to send and update that change set so that the people in the logistics center can actually see, oh, okay, they're done with their delivery, right? It's fun. We actually even had a GitHub user filing issues for us from who's actually a farmer in Africa, and he's like making apps for farming. Africa typically doesn't have very good low latency, and so he's able to actually do some tracking of his farm farming operation using Realm and Sync. So
okay, so basically, it's from what I'm hearing is that it's good for everything, but especially good for like local first database, which it is for low network conditions, stuff like that.
Right. Yeah. It's also nice, like if you do want to have, just the local part of Realm, like if you have an application that's like a note-taking application or anything like that, it's nice to use Realm because your data is stored in kind of more of a database instead of just a giant file. Like it'll take up less space on your disk. If you're right.
So I was going to also ask, because we already discussed how to set it up in my project, but how do I set up this synchronization? Do I need my own server with MongoDB, or do you have some kind of maybe pre-made solution that I can hook into?
There is a little bit of a setup. We're trying to make it easier and easier, but we have a free tier for Sync. Like Sync itself isn't free, but after you scale to a certain point, but you do need to set up an Atlas cluster. So basically, you can make an account on MongoDB and set up an Atlas, and then you deploy a cluster, and then you create it. Basically, it's under App Services. You create an application, and that is what you can use to start Sync. We do have some easier ways to get started. Like if you, we're going to share some links, the getting started tutorials, which will deploy basically like a to-do list app and automatically set up like your Atlas and app services for you. And I'm wanting to like make a command line tool in the future where you can basically just say like React Realm init, and then it will just set up that background for you. But yeah, so let's take that back a little bit. So once you get set up with app services, you basically create a Realm app. You set up authorization of some kind. You can start off with, say, anonymous login if you just want to get started without thinking about, setting up email addresses and passwords. And then you enable flexible sync, which will basically set up the synchronization service for you. And then you can enable that in developer mode so that when you set up your classes in your application and start writing and using it automatically, it will do the work of setting up the schemas that talk to MongoDB. So it sounds pretty complicated.
It does,
once
yeah.
Once you get started with it, it's great. We're trying to make that even easier every day. But that is definitely like one of the toughest parts to get started.
But it's also like from my podcast experience, it's quite hard to explain technical topics without visuals, without like examples of like, here is the dashboard and here is this piece of code that I'm like, it's harder to describe the piece of code than just show it, and like everyone would understand it when they see it. So like you said, we're gonna link everything that we are talking about in the show notes so that everyone can go there and just set up their first chat application with with Realm.
Right.
Yeah, please.
Oh yeah, I was just gonna mention like we can add also in the notes. Like I did a session with Yaman Holmgren from React Native Live, where we basically did a live stream on Twitch setting up a React native app with Realm and Sync. So like the first half of it, we just set up a local to-do list app, and then the second half of it, we did the entire Atlas cluster set up and get everything worked on, and ran into issues and solved the issues. So it was good. But at the end of it, we got it working. So if you want to check that out and see how that could be done, and what problems you might run into, that's definitely worth checking into.
We're gonna link a show from Jamon as well in the show notes. Jamon is actually from Infinite Red. They just had a Chain React conference, and they are doing React Native Radio, which I'm a fan of. And he also does the live session with coding. So I really enjoy watching him doing all of that.
Right.
I want to move on to like maybe discuss some of the distinctive features that Realm provides to developers and to like app performance and all of that. If you could speak something to this.
Right. So we've got all these points, but I want to talk about like how, as I said, each SDK that Realm has is developer focused. Like we're thinking about how can you make it so that the database, which is, you know, usually a super complex thing, like you don't want the developers to have to think about a database. You know, you want things to just, you want to focus on your application that you're making. You want to get your idea off the ground. So the way we do that, as we talked about before, like having objects in that you can access in Realm that are basically the same as their JavaScript counterpart. For example, like the collection you get back from Realm looks and feels like an array, right? You can plug it into the data property of a flat list. You can index it. You can call map, filter. You can run for each methods, iterable methods as well. The next feature is would be like live objects. Like the data that you get is always, it's never stale. It's always the like every write you make, you're always having access to the version, the correct data. And then what's also nice about Realm is the hydration period. Like if you're using something like Redux Persist or Mavic State Tree, you'll have to basically have a hydration period, right? You're going to have to, what does a hydration period mean? Basically, when you start your app, you're going to have to load that state somehow into memory. And usually the way that's done is that you'll use something like async storage or persistence library under the hood, which is going to have to parse that data that was stored and convert it into a JavaScript object. And then at that moment of time, it sends an event list. It fires an event list into your app to let you know that the hydration is done and your app can carry on and use that data now. With Realm, if you have access to your if you have that local database, you basically can open it directly right away and immediately have access to your data. We don't have to load everything into memory at once. We can use memory mapping features to make sure that you just get access right away. And as you start accessing your data, it'll start loading things into memory, right? So if you have a collection of, you know, hundreds of thousands of items, you're not going to put hundreds of thousands of items in your memory right away. You know, you're going to get a page of data.
It's faster.
Right. Exactly.
Yeah. Okay.
Right. And then other than that, when we're talking about sync, you also get Atlas. You get access to the MongoDB Atlas features as well on top of that. So basically, outside of the Realm database object that you have, there's also an app object, which we provide providers for, and also a user object, which is your authentication. And from there, you're able to basically call things like function triggers on your Atlas database. So if you need to do any like MongoDB specific things, and you know MongoDB quite well, you can actually call function triggers and pass them params, and then, you know, you'll have functions in like serverless functions within the MongoDB cloud that can be triggered to actually work on data, right?
Oh, okay. That's interesting. Yeah.
Right. And at the end of the day as well, like even if you did set up Realm with sync and you wanted to do something besides like React Native development, you can also like create a GraphQL interface. Like MongoDB offers a GraphQL interface to the data. It can also generate a REST database to your data. Right. And
okay.
yeah.
Maybe what we could do now is also take a look at the future for Realm. What are you cooking for us that is not released yet? If you can speak something to that.
Right. One thing one of our teams is working really hard on is WASM support. so that we could run Realm actually in your browser. So I would love this because after I was at the last conferences and seeing all the fun things that Expo's doing with like routing and stuff like that, file-based routing, I was like, you really want to share all your code, between your React Native app and your React front-end app. And if we can get the WASM support released, and it has the same, it's
API,
also just npm install Realm and npm install Realm React, you would be able to share code between your web application and your Realm application. Yeah. We do offer Realm Web today, but it's basically giving you a MongoDB client that you can talk to, and does like the authentication things and stuff like that. But you can't actually like work with Realm in a classic sense in the browser today. So that's super exciting. We actually have alphas out for that now. There's actually people experimenting with it. So you can definitely check that out. Yesterday, I just pulled the trigger on a release candidate for version 12. We're pretty excited about this because Realm classically, like Realm.js classically, was mostly written in C++. So you would have basically methods that you were invoking that would just immediately be C++ calls. And for us, that was a bit tough to maintain when we wanted to make new features. So basically now we've created this binding generator that'll just wrap Realm core and give us a TypeScript interface to it. So now we can actually use like our team can access the Realm core itself as a TypeScript interface, and then write all the SDK code in TypeScript and JavaScript. I think this is going to be really cool because now people using our code are going to be able to step into Realm and actually see what's going on under the hood, and maybe submit some pull requests or file some bug reports with actually this context, because classically it was difficult to see what happens once it goes into C++ land. All right.
Yeah.
And we've done some performance checks as well, and like we're not taking too much performance hit doing this, so we're really excited about it. So that's been released. Basically, if you update from 11 to 12, you shouldn't have to make any changes to your code. Like, we did the best we could. We had to hold back from making breaking changes, but yeah, version 13 will be the fun one when we actually get to improve on that. And then also Realm React itself, I just released a new version, 0.5. This includes hooks to make it easier to authorize your app. So you got to use auth hook that you can use. Basically, if you're setting up your Realm app for sync, you have a user provider that has a fallback property when you don't have an authentication session, and then it'll render what's in that fallback. So I made these hooks that when you're in that fallback, you can just use these authentication hooks to have a simple interface. For instance, you call login with email and password, which you pull from useauth, and it also has it has a result object that shows you the state of the operation you made. So when you call login, then it'll say, okay, this is pending, or there is an error, or it was successful, and then you can update your UI with that.
It's like
right. Yeah. So yeah, exactly. So it's just like an async operation, but it's wrapping the authentication parts of Realm. And then use query has been updated, as I said, to use these the callback with the to set up your queries and your filtering and sorting. And yeah, we're constantly gonna keep looking for community feedback. So Realm React is a work in progress. Like I was really excited to make it and actually make it so that Realm was easy to use. So we're definitely looking forward to more community involvement and seeing what people think about it. And we welcome anybody to submit issues or feature requests and let us know what we can do. We're listening. We're very active on GitHub. So
and on podcasts and on React Native Live as well.
Yeah.
So I really appreciate you coming into the show and talking with me about this. I'm not really into databases, so that was a very nice opportunity for me to like learn more about the differences between the different kinds and like what I can do with them. And I'm gonna definitely check out the synchronization, because I feel like from my newbie database perspective, this can allow me to like omit using the API calls entirely. So I'm gonna check that. Andrew, thank you so much for coming into the show. Thank you everyone that was listening. We will link everything that we discussed in this episode in the show notes, like Realm React, like MongoDB, React Native, and like React Native Live with Jaemon that lasted 3 hours. Yeah. Thank you so much.
Yeah, thank you. It's been a pleasure.